Here we have a couple of more examples of definite integral properties. In the first one, we are told in advance that the integral from 1 to 3 of some function f of x with respect to x is equal to negative 5, and we're asked to consider the integral from 1 to 3 of 4 times f of x dx. Well, we know through constant multiples that we can think of this as 4 times the integral from 1 to 3 of f of x dx, which means that this is 4 times negative 5, or negative 20. Essentially what we're doing is stretching the function. It stretches above the x-axis for the positive values by a factor of 4. It stretches below the x-axis, that is the y values, also by a factor of 4, spreading everything out. And it turns out that also increases that kind of area or net area by a factor of 4 at the same time. In the second example, we're told that the integral from negative 2 to 2 of some function g of x with respect to x is 7, and on the same interval, we're told that the integral from negative 2 to 2 of some function h of x with respect to x is 5. We're asked to consider the integral from negative 2 to 2 of g of x minus h of x. Well, what we know from our sum and difference is that we can consider this to be the integral from negative 2 to 2 of g of x dx minus the integral from negative 2 to 2 of h of x dx. So that becomes 7 minus 5, or we end up with 2. So as we could with indefinite integrals, from these two examples we can see that we can take constant multiples and move them outside the integral symbol, and we can also take integrals that involve sums and differences and break them up into smaller pieces so that they're easier to deal with.